Hi, hello everyone. In this video, we are to continue with engineering graphics. Here we are to look at a topic dividing things geometrically. In day-to-day life or in drawing, we have needs to divide things. Of course, we can measure and do it, but doing things geometrically has various applications. For an instance, in day-to-day life, when we are in need to divide certain things, we do it differently rather than going by measurements. For an instance, if we consider a thread, if you want to divide it into two equal parts, what do? We just take the ends and connect it, then we stretch it. We find the midpoint, right? We divide the thread into two equal parts. In the same fashion, if we want to divide a stick, we can do it by various forms. If it is a homogeneous one, if it is even, then even we can balance it. If we can balance it correctly, then we will be able to find the midpoint of that one, right? Not every time we can do that because the stick could not be as we expect, right? Then we may have to just approximately find that. That is another option. If not, we need to use a tape. We need to use a measuring tape. We need to measure it. Then we need to find the half distance. That is another way, right? Here, these are some of the applications that we do it in the day-to-day life. Here, if we want to divide something in drawing, for example, a line AB. If we want to divide this into two equal parts, or else if you want to bisect it, what do? Considering a line AB. Here we have studied, we have even done this earlier. With the help of a compass, we can do this easily. Just taking more than half of the length of the line AB with A as center, making an arc above and below. Now, without changing the radius, with B as center, cut an arc above and below, naming these things as P and Q. Now, when we connect P and Q, we get a point of intersection C in the line AB. Now, while measuring AC, which is definitely equal to CB, here we have divided a line AB into two equal parts, or else we call it as bisecting a line. The interesting thing is the line PQ has not just bisected the line AB, it has also made a perpendicular line to AB. So, with this, even we can find some other applications. Whenever we are in need to draw a perpendicular line, even in drawing or even in practice. Here, considering a line AB, if we want to create a perpendicular line to this AB, at any point we can decide. In this case, I have decided to find a point C. For this point, we need to have a perpendicular line. Just recreating this here. Considering the point C with a radius, I have made an arc on either sides. Have named it P and Q. Now considering PQ as the line, as we did over there, taking more than half, making an arc above and below with P as center, without changing the radius, with Q as center, cutting that arc above and below, naming it as R and S. Now connecting R and S, that will give a perpendicular line passing through C. That is our requirement, right? So, if there is a line, we can create any parallel, any perpendicular lines at the place where we want. That's good, right? Now, coming back to this one. Here we have divided the line into two equal parts. In the same manner, even we can bisect an angle. That angle can even be acute or obtuse, whatever the thing is. Considering an angle ABC. Now we need to bisect this. So, having B as center, taking any radius, you can make an arc on both the arms, naming it as P and Q. Now with P as center, making another arc without changing the radius, with Q as center, cutting that arc, naming it as R. Now connecting R with B, this angle PBR is equal to angle RBQ. This is how we bisect an angle. Just like this, here also we can make half of the arc. Considering arc AB, just like a line AB, we can do this, taking more than half with an arc above and below without changing it. From the other end, just cut it above and below, connect it, the point which will be there, that will give half the distance, right? Now, with this, even we can go further. The line can get divided into 4 equal parts. How to do it? Considering a line AB, just like this, we can take more than half, making an arc above and below, without changing the radius, with B as center, cutting the arc above and below. We have got point C, as we did over there, ACCB, ACCB. We have got 2 divisions, right? Now going to this end alone, with C as center, making an arc above and below, with B as center, without changing the radius, cutting it above and below. Here we have got D. Now, DB or CD, both are equal actually. Take this and make another arc. Now we will find that AE is equal to EC is equal to CD, which is also equal to DB. Here we have divided the line into 4 equal parts. The same fashion we can even extend it to divide it into 8 equal parts or 16. But do we always recur things like this, 2, 4, 8? Not necessarily. Even the requirement could be a bit different. We may have to divide a line into any number of parts, maybe 3 or 5 or 6, which is not in this category, right? Even we can do that geometrically. Let us see, considering a line AB, we need to divide this line into 3 equal parts. Already we have heard things like this, a line, without touching it, would it be possible to make it shorter? Yes, of course. While we draw a line close to that, which is longer than that, we have made this line, which was there, shorter without even touching it, right? In the same fashion. Here, we want to divide this line AB into 3 equal parts. Now, what we do is, we draw another line starting from A at any angle. It is not necessarily to be a particular angle. Even you can have any angle, have drawn a line from A. Now, I need to take a length, okay? Just starting from A, we have marked 1. Without changing this, I continue to do this. Okay, as we need to have 3 divisions, we have made 3 divisions on the new line what we have made. But our objective is not this one. We want to divide AB into 3 equal parts. The interesting thing comes here. Connecting 3 with B. This is our reference. Connecting 3 with B with a ruler. We can use a ruler. We can just connect it because the last point is known. Here we have the last point that is also known. Now the only thing that we need to do is we just want to create parallel lines. How can we create parallel lines? We can use a mini drafter or else even a set square. You can use a set square, you can do it. How to do it? Of course, we know that having a mini drafter, we will be able to create it like this. Just as we do it, we can drag it. We can have this way, then we can drag it, we will be able to create parallel lines. Now, with the help of a set square, how will we be able to do it? Setting the last line, that is connecting C to B. This is our reference. Now, holding a ruler parallel or considering with the base. Just like this we need to have. Now, this is the base. I need to hold this firmly. Just drag this to the place where we need to draw line. Like this, while we draw, we will be able to draw any number of parallel lines. So, the last one, point 3 to the end. Now we extend it from 2. Now we draw another one from 1. By doing this, we have got AD, DC, CB. If we measure it, all will be equal. We can even try this with a known length. but here we have done it with an unknown length. In the same way, even we can do it for 5 divisions or 6 divisions or even for 4 divisions. This method shall be used. Here we see that AB, we need to have it into 5 equal parts. As we did here, we have made another line. We have taken the compass with a particular radius. We have marked it. Now connecting the last one with the last one, then we have made parallel lines. Just we have made parallel lines on all points. So now we see that AF is equal to FE is equal to ED is equal to DC is equal to CP. All are equal. We have got the 5 equal divisions. This is interesting, right? So this is very important. How to create a parallel lines. How to create parallel lines. Of course, with the help of mini drafter, we can do it easily because that has two perpendicular scales. Without even having a mini drafter, with the help of set square and the base, we can do it. Okay, good. Now, another thing is, with this concept, even we will be able to do ratios, proportions. For example, if we want to have a line divided into some ratios, say here we have made it as 3:4. A particular line need to be divided as 3 parts and 4 parts. So, making cumulative of these things, 7 parts. With the same method, we have drawn another line. We have divided that into 7 equal parts. Now the thing is, connecting the last one with the last point. The only thing that we need to do now is, we want only one point. Here we need to have 3 portions, right? 3 parts. So count 1, 2, 3 here. What about the remaining? Here we need to have 4. 1, 2, 3, 4. So connecting the third point with a line parallel to the base. Sorry, I repeat. Here we have a line already made. We have made the last one there. Just have it like this. Now this way, you can just drag it. You will be able to get a line on the point 3. Extend it. That will give an intersection on the line AB, which is nothing but C. So AC is to CB. That will give 3:4. This is how we will be able to make even ratios. This is interesting, right? These things are very much important in making drawings. We don't calculate using a calculator. We don't divide it by just measuring. We do things geometrically. This will definitely be helpful in various parts of the drawings. While we come across, we'll look at it. Thank you so much.